Hello.
We get it. Losing a customer to a failed payment is a failed payment. But with Razorpay pay,
Hi students, so very good morning everyone. Welcome to this next session after the gate examination. Now we bring up the sessions on BARC. This is the first session on control systems, and similarly you can expect other sessions on other systems by the team of Home Institute. So yes, come on, quickly update all your friends that the session is live so that everybody will join. Okay, it's going to be a revision for BARC for control systems through questions. Okay, so that you also see the different models of question expected as per BARC level, and also at the same time you revise relevant theory and formulas with respect to them. Okay, all. So yeah, come on, let everybody join quickly. Yes, very good morning everyone. Okay, so yeah, let's get started meanwhile. So this is the first question. Okay, as I told you, with questions we are going to revise up the entire things. Okay, so for the signal flow graph shown in the figure, what is the gain C by R? Okay, so now for the signal flow graph, what do you apply? Mason's gain formula. To solve the C by R, you will apply here Mason's gain formula, which is given by what? Summation Pk del K is divided by delta. Okay, summation Pk del K is divided by delta. Okay, where Pk is the kth forward path, delta K is its respective path factor, delta is the overall graph determinant. Okay, now if I want to find how many forward paths are here, okay, how many forward paths are available here? So as you can clearly see, okay, let's come up here. There is one forward path, that is this direct horizontal connection from R to the C. What is forward path? Any path from the input to the output. Okay, so if I mention the forward paths here separately, if I mention the forward paths here separately, okay, so the first forward path P1, as I told you, that directly the horizontal path from the input to the output, and the gain will be 1 into 2 into 3 into 4 into 1, which is how much? 24. Okay, the second forward path, as you can see, okay, you have to follow the direction of arrows, and this particular path from input to the output going through this branch of gain 5. Okay, so the next forward path gain is 1 into 5 into 1, and that is equal to 5. Now, what are their respective path factors? To find out the respective path factor, it is important to first analyze the loops. Okay, how many loops are available in this graph? So that you will also be able to say the graph determinant. How many closed loops are available? Very clearly you can see this loops L1, L2 and L3. Okay, this is very clearly visible. Then there is one more loop that you can think that goes from this bottom branch 5, then minus 1, minus 1, minus 1. Okay, this also makes the loop closed here, starting and ending point same, and this is known as loop number 4. Okay, so there are the 4 loops that I am able to see here, and they are respectively, okay, first is minus 2. Okay, then 3 into minus 1, this is minus 3. The next loop that I have highlighted here is minus 4, and the next loop that I have highlighted here is, okay, 5 into minus 1, minus 1, minus 1, which is equal to minus 5. Now, I hope you can clearly observe that this bigger loop that I have taken L4, okay, L4, if you see like this again, it touches L3, it also touches L2, it also touches L1. Okay, but then L2 also touches L1 and L3 both. But L1 and L3 are the 2 loops which are not touching to each other, very clearly, I think, visible to you. Okay, so out of these 2, I can also mention that L1, L3 are non-touching to each other. L1 and L3 are non-touching to each other, correct? The L1 and L3 are clearly non-touching to each other. L1 and L3 are clearly non-touching to each other. Okay, now if they are non-touching to each other, okay, we know what to do in the graph determinant. So let me write down that graph determinant now. Okay, yeah. Writing down the graph determinant. What is the graph determinant? 1 minus sum of all the loop gains. Okay, all the loop gains will be taken as L1 plus L2 plus L3 plus L4 plus product of non-touching loop pairs if there are non-touching loop pairs. So there is only one pair which is non-touching, L1, L3. Okay, so their product will come up. Okay, so feeding down the data 1 minus, now L1 plus L2 plus L3 plus L4 total minus how much? Minus 9 minus 5 minus 14. Total sum is minus 14 and plus L1 L3. What is L1 L3? Minus 2 into minus 4. Okay, so this is also 8. This is also 1 plus 4. 15 plus 8, 23. Graph determinant is 23 here. Okay, the graph determinant value is 23 here. Done? Okay. Now other than the graph determinant, let me also write down the path factor here. Okay. What is the path factor here? Delta 1. What is the path factor? What is the meaning of any path factor? As I told you, the formula is summation p k del k. How many forward paths I got here? Okay, I got 2 forward paths. Okay, so my C by R should be written this way. My C by R should be written as P1 del 1 plus P2 del 2, summation for 2 forward paths divided by delta, out of which delta we have calculated. P1, P2 we know. What is delta 1? So what is any path factor? Path factor is the graph determinant obtained after deleting the particular forward path, right now? Okay, when you delete the particular forward path, so when you delete P1, okay, suppose if I erase this first forward path, which was my horizontal line, when I erase this, you can see L2, L1, L3, all of them become open. Their branch go away. L4 also becomes open. The nodes go away. Okay, and loop means closed loop. Okay, so very clearly, no closed loop is left. And whenever there is no closed loop, what is the determinant formula? Only one. 1 minus loop gains will come if there is a loop. So there is no loops. So delta 1 is 1. Now similarly, what is delta 2? So when I erase the second forward path, what is going to happen? See, this was my second forward path, through this bottom branch, through this bottom one. When I erase the second forward path, what is going to happen? You see here. Okay, what is going to happen is, okay, L3 is open, L4 completely open, L1 also open here at this node, this also gone, but there is one loop which is intact, not disturbed, and that is L2. That is L2. So what is the graph determinant of the remaining graph? Okay, the graph determinant of the remaining graph here would be 1 minus L2. L2 will be still intact, and what is the value of L2? L2 was how much? Minus 3, and net answer is plus 4. Now feeding down the data here, P1 was 24. Okay, its path factor is 1. 24 into 1 plus P2. What is the P2 value? Is 5. Its path factor is 4 divided by delta, which was 23. So 24 plus 20, 44 divide by 23. 44 divided by 23. What is that answer? Option number A. 44 is divided by 23. Option number A. Yes. Yeah, Sai Vikas giving the correct answer. Option number A. Okay. 44 divided by 23 is the correct answer. Option number A. Correct answer, Sai Vikas. Right? Yeah. Now, let's be ready for the next question. Take the next question. For the signal flow graph shown, find x5 upon x2. Check the question clearly. You have to find x5 divided by x2. Find x5 by x2. x5 by x2. Okay. Now see, Mason's gain formula. We should also know that in Mason's gain formula, you can take any output node, not necessarily the valid final output node, but input node has to be a valid input node. Okay. In the Mason's gain formula, is x2 a valid input node? What is the input node? What is a valid input node? Is input is something that enters to the system. So it will only have outgoing line like x1. Okay. X2, it has an incoming line. It has an incoming line. X2 is not a valid input node. Okay, so what is the problem here is X2 is not a proper input node, or also I call it as not a valid input node. Whenever you don't have valid input node, MGF directly can't be applied. I hope you are aware about this limitation of Mason's gain formula. Mason's gain formula directly can't be applied. Okay, Mason's gain formula directly cannot be applied. Cannot be applied. So what to do if MGF cannot be applied? Then what do we do in such cases? Understand here. question is x5 upon x2, we do it this way. What is the valid input node? X1. Okay. What is the valid input node? Is X1. Okay, this one is valid input because this does not have an incoming line. This is the only input which enters, which has only outgoing line. I will write down this equation as x5 by x1 divided by x2 by x1. Correct, na? All right, now answers are there. Unlocking and Sai Vikas says answer D. Okay, we'll check it. X5 by x1, x2 by x1. X1 actually cancel, you will get x5 by x2. But what I'm trying to do is, I'm trying to write down the numerator and denominator such that the input node is x1, valid input node. I told you output node could be anything. Patel also says answer is D. Output node could be anything, right? Okay, so now what is x5 by x1? Now what is x5 by x1? See, to go from x1 to x5, there is only one forward path. There is only one forward path. Okay, so that is 1 into its path factor. We will see that divide by delta. Okay, acha, how many loops by the way? Very clearly you are able to see these are the 3 self loops, L1, L2, L3. Only self loops are there, out of which L1 and L3, and sorry, not only L1, L3 here actually. Okay, L1 and L2 as well as L2 and L3. Okay, this is also non-touching, this is also non-touching. So you also have a non-touching loop triplet. Okay, but yeah, now when I erase the first forward path, x5 by x1, this is the forward path, and when you erase this forward path, dear, when you erase, what will happen? This loop open, this loop open, this loop also open. Okay, so there is no loop going to be left. So what is the path factor? Okay, path factor will be 1 divided by delta. Let the delta be as it is right now. Okay, divided by x2 by x1. Now be careful here, x2 by x1. X2 by x1, what is the forward path? Okay, x2 by x1, forward path is only equal to 1. Okay, only this much. Okay, but then when you delete this forward path, okay, one loop gone, but L2, L3 are still left. L2, L3 are still going to be left. Clear, na? L2 and L3 are still going to be left. So when I take x2 by x1, the forward path value is still equal to 1. The forward path value is still equal to 1 multiplied by how much? Okay, multiplied by path factor, and path factor is the graph determinant of remaining graph. Remaining graph L2, L3 are still left. 1 minus L2 plus L3. And L2, L3 are also non-touching. So even product L2, L3 will come up. Divided by delta. Now see, graph determinant is the determinant of the entire graph. Whatever input output you take doesn't matter. So that is why delta not required here. It is going to be cancelled. Very clearly you should observe that this delta will cancelled, and the answer is equal to, final answer for x5 by x2 should be equal to 1 divided by 1 minus, okay, L2, L3, minus B and minus B, so minus minus plus 1 plus B plus C, and plus product of these two will be BC. Okay, 1 plus B plus C plus BC. Okay, which is going to match with answer number D. Which is going to match with answer number D. Okay, which is clearly going to match with answer number D. Right? Which is going to clearly match with answer number D. Okay. Now there is one more possible way you can solve it. There is one more possible way you can solve it. Okay. Now I wanted to illustrate this MGF limitation. That is why I have taken this way. Another way that you can solve this is, see, a simple calculation. See, if you want to write down x5, what is x5? x5 is simply equal to x4, right? Okay, only one incoming line. Then what is x4 equal to? Then what is x4 equal to? Okay, if I want to write down x4 equation, okay, x4 is equal to, one line is coming from x3 and minus cx4. Okay, minus is the self loop. Okay, so from here, x4 you can send on the left side. Okay, so you will get x4 into 1 plus c is equal to x3. Okay, let this be like this. Then similarly, if I want to write down x3 equation again it has one incoming line from x2. Okay, and one self loop line minus b times x3 only. Again shift the x3 on the left side. x3 1 plus b is equal to x2. Correct? Correct. Now, how to solve this? Okay. x5 divided by x2. Number one, x5 equal to x4 only. So that is x4 divided by x2. x4 by x2 is how much? What is x4? It can be written as, or let me write this way, x4 by x3 into x3 by x2. What is x4 divided by x3? So x4 divided by x3, 1 upon 1 plus c, multiplied by x3 divided by x2, 1 upon 1 plus b. Same answer, na? Same answer, na? 1 upon 1 plus b, 1 plus c. Same answer, D. Okay. Yes, Tirumala, correct answer. It is D. Anyways. Okay. Anyway, so these are, one is simple equation and one is the Mason's gain formula, but that cannot be applied directly. You have to be careful. That is what I wanted to highlight. So I have taken that particular approach. Okay. Next question. A unity feedback system has the open loop transfer function given k upon s, s plus 10. If the damping ratio is 0.5, what is the value of k? If the damping ratio is 0.5, what is the value of k? Very simple question it is. Okay, so some questions can be straightforward as well. Okay, what I will do is I will directly write down the characteristic equation. What is that characteristic equation? 1 plus GSHS, unity feedback. So only 1 plus GS equal to 0. Normally, how do you write down the characteristic equation? 1 plus GSHS equal to 0. HS is given as 1. Unity feedback has been mentioned here. Okay, so when you simplify this, S square plus 10S plus K equal to 0. Now, what is mentioned? Damping ratio. Damping ratio means what? Zeta. Zeta is given as 0.5. Okay, zeta is given as 0.5. So, here, if you take, this is the term 2 zeta omega n, which is equal to 10. Zeta, as I told you, 0.5 is given. Okay, 2 into 0.5, 1. So, what is left actually? Omega n. Omega n is 10. And then what is this K? The general standard characteristic equation, second order system. Okay, has omega n square here. So, k equal to omega n square, and omega n square will become 100. Option number B. Option number B. K equal to 100. Right, correct, Winterchild. Yeah, anything. I told you, the two methods I have given you. Okay. See, why I told you this method also. Okay, MGF limitation. Because sometimes graph may be complex. Okay, we can't deal with equations so easily. So, Mason's gain formula will easily fit in there, but you should know the limitation. Again, I repeat, it can have any output node. You can take any output node while using FGF, but input node has to be valid input node. What is a valid input node? Which has only outgoing line, which enters the system. Okay, valid input node, only outgoing line has to be there. That is the way to identify valid input node. Correct, na? Anyways, then we'll go to the next question. Okay, yeah, this was anyways done, easy one. Yeah, for the second order system, the location of poles is shown in the figure. Find the peak time and approximate settling time. Now see, complex conjugate poles are given. Okay, and the location of poles, okay, for second order system, especially if they are complex conjugate, the complex conjugate nature of poles for second order systems is actually given by the formula minus zeta omega n plus minus j omega n root over 1 minus zeta square, which is also minus alpha plus minus j omega d. Alpha is known as what? Damping factor. Okay, which is zeta into omega n. Omega d is what? Damped frequency. Omega n root 1 minus zeta square. What is the question? Peak time and settling time. Number one, what I can find out? Okay, minus alpha plus minus j omega n. What is given to me is minus 2 plus minus j5. See the location of poles. Okay, minus 2 plus minus j5. Okay, now come to the formula. Okay, what is the peak time formula for the second order system? The peak time is given by the formula simply pi by omega d. Okay, so what is omega d? If you compare, omega d is directly 5, finished. Okay, so peak time is pi by 5. Okay, then approximate settling time for 2% range. For 2% range for second order system, a second order underdamped system, poles are complex conjugate, means the system is underdamped. Means the system is underdamped. Okay, now what is that settling time? Settling time is given by 4 by zeta omega n or 4 by alpha, 4 by 2, and that is equal to 2 seconds. Settling time 2 seconds, peak time pi by 5. Simple one. Okay, I did not give any options for this, but yeah, this is also one more type of question where poles are given and that connection with the formula like peak time, settling time, etc. Can be explored. Have a look into this next question. Two unity feedback systems A and B with the open loop transfer functions are given to you. Okay, two unity feedback systems A and B with open loop transfer functions are given, GA and GB. Okay, Which of the following statement is correct? A has higher overshoot or A has lower overshoot? A has lower settling time than B, both have equal settling times. Okay, now overshoot depends on what? Okay, overshoot, see, as I told you, overshoot, okay, or if I say percentage overshoot, or let me simply call it as overshoot only, okay, given by the formula e power minus pi cot phi, this is how I write, or also written as e power minus pi zeta upon root 1 minus zeta square. Important point, it depends only on zeta. That too, how it depends on zeta? That too, how it depends on zeta? If zeta increases, overshoot decreases. It goes reverse, inverse. Okay, then settling time, as we just revised with the previous case, what is the settling? Or 4 by zeta omega n, correct? Okay, so we have to compare, the parameters of the two system given. Okay, so yeah, these are the GA and GB two systems. What are these? These are unity feedback and open loop transfer function is given. We have to write down the characteristic equation for corresponding to first one, 1 plus 9 by s plus 1 equal to 0. So solving it, what do I get? S square plus s plus 9 equal to the 0, correct na? Right. Now see here, omega n square is 9, omega n equal to 3, omega n 1, this is the first system, okay. Then 2 zeta 1 omega n 1 is equal to 1, this is 2 zeta omega n. So 2 zeta 1 into what was omega n 1 into 3 is equal to 1. Zeta 1 is 1 by 6, okay, this is done. Okay, now let me come to the second system. What is the characteristic equation for the second system? 1 plus GSHS again equal to 0. When I simplify this, I'll get s square plus 2s plus 16 is equal to 0, correct? Okay, now again here what is the value of omega n square is 16. That means omega n 2 is equal to 4. Then 2 into zeta 2 into omega n 2, which is 4, equal to 2. What is zeta 2? 1 by 4. 2 and 2 got cancelled. Zeta 2 is 1 by 4, correct? Now we have the values that we can compare. Okay, now we have the values that we can compare. What is the comparison of the values? First, zeta. Which zeta is greater? 1 by 6 or 1 by 4? 1 by 4 is more, na? Zeta 2 is greater than zeta 1. More zeta means less overshoot. Zeta higher, overshoot lower. Okay, so the overshoot for the second system is less than the overshoot for the first system. That is one point. Okay, the overshoot for second system will be less than that of the first system. Okay, so A has lower overshoot, then the answer is B only. Finished. Only one option correct, na? MCQ. BARC has only MCQ questions, not MSQ. Okay, but yeah, I'll still tell about settling time. Now, if you see settling time comparison. Okay, now if you just want to see the settling time comparison. Okay, what has happened? Okay, what is the alpha 1? Okay, alpha 1 is directly zeta 1 omega n 1. And from here it will be 1 by 2. Okay, directly writing alpha only. Alpha 2 is zeta 2 omega. Okay, what is the product of zeta omega n from here? Zeta into omega n, 2 and 2 will get cancelled. That is equal to 1. Okay, 2 zeta omega n is 2. Okay, so which alpha is greater now? Okay, which alpha is greater? Alpha 2 is greater than alpha 1. Okay, and alpha more means settling time less. Again, that is inverse relation. Okay, so that means the settling time of the second system will be less than the settling time of the first system. Okay, now they have equal settling time, wrong, but A has lower settling time? No, the second system has lower settling time. Okay, so that is why only answer correct is B. Okay, the correct answer is B. Hope you got this. Tell me if there is any particular doubts or something. Okay. Or else you can look into the next question and answer. Okay. Yes, guys. Check the next question now. The answer correct is B. Okay, the correct answer is B. Sai Vikas, B it is, not C. Just check it out once again. The answer turns out to be B here. Okay. Okay, yeah. Next one. The second order response is given below. Find the value of damping ratio. Okay, now damping ratio, the best thing is you can take the overshoot. Okay, there is one more thing, you know, what is this? Okay, this is the value of the time at which the peak overshoot occurs. Okay, this is what? This is the value of the maximum output. Let us say this is the response of the system CT. Okay, this is the maximum value of the CT. Okay, this is the settled value, desired value of the CT, the value where the system will settle. This is the CT desired. What is this? This is known as the peak time, TP. This is known as peak time. But what is peak time formula? Peak time is pi upon omega d. Omega d is again containing both omega and zeta. I only want zeta, so better to use overshoot. Now, what is overshoot? Okay, overshoot, basic definition is given by the deviation, the maximum possible deviation with respect to desired value. Okay, so see, this much is the deviation. This much is known as the deviation, the maximum positive deviation compared with the desired value. Okay, compared with the desired value means divided by CT desired. Okay, now what are these values? 1.254 minus 1.04 is divided by 1.04. We can calculate, and then also we can eventually use, what is the formula used here? E power minus pi cot phi is, how much is this value? Okay, let me just calculate and write down the answer here. Okay, 0.205, 0.206, let me take approximately. In BARC also you have the calculator, scientific calculator, sorry, not scientific, virtual calculator allowed. 0.206 approximately, I got this. Okay. Okay. Now see, overshoot given and you have to find zeta. Overshoot given, you have to find zeta. I'll give you two different ways. Okay. Overshoot given and you have to find zeta. Okay. You have to find zeta. Okay, that's I'm telling. Method number one. Okay, forget this here. Okay, for overshoot given, you have to find zeta. Now, what is the overshoot? That's what I'm telling. Overshoot means e power minus pi cot phi. E power minus pi cot phi, or e power minus zeta upon root 1 minus zeta square, whatever formula you have remembered. Okay, so number one is you can deal with this calculations as well, because calculator will be there. You will have to take log on the right side, log 0.206. Okay, first calculate tan phi, because your calculator will have tan inverse rather than cot inverse. Okay, what is tan? 1 upon cot. Okay, so if you take tan phi, it is minus pi, log will come up here. Okay, let me see how much is this value turning out to be actually. Okay, how much is the calculation I am getting? Minus, sorry, plus only, minus already is there, 1.988. Okay, then you can calculate the tan inverse and write down the value of the phi. Okay, so when you take the tan inverse here, sorry, sixty-three point three. 63.3 degree. Okay, then what is zeta? Zeta is cosine of this phi. Okay, and when I write down the cos value of this, what is the answer? Approximately I am getting 0.449 or 0.45. Writing down up to 2 decimal places. 0.45, right? Yes, correct. Sai Vikas and Samukha, correct. 0.449 or 0.45. Now, other way what I am telling you is, overshoot is given as e power minus pi cot phi. Okay, or as I told you, other way you might have also written this formula this way, e power minus pi zeta upon under root 1 minus zeta square. From here, whenever overshoot is given, you can also use this formula, minus log overshoot divided by under root of log of the overshoot whole square plus pi square. Okay, you also can use this formula. So you just have to fit in the value of the overshoot that is obtained, 0.206, divided by under root ln 0.206 whole square plus pi square. You solve this, okay, answer approx 0.45 will come up, okay. Answer approx 0.45 will come up, okay. Yes. The sessions for, yeah, I'll plan for maths also. Session for core subjects will also come up, like machines and power systems, power electronics for EE, and the session for electromagnetics and analog for EC will also come up. I mean, analog still will be common for both EC and EE. Okay. Right. Next one. What is going to be there? The next one. Okay, yeah. A unity feedback control system has the forward part transfer function. Okay, if the system is subjected to the input RT equal to 1 plus 2t plus 5t square, the steady state error. The question is on steady state error. Okay, and very good, already unity feedback is given. Okay, unity feedback is given. Now, from the unity feedback system, we can define the type of the system. Okay, number of poles of GS at origin. When unity feedback is there, number of poles of GS at origin is seen. How many poles at origin? 2 poles, S square. So what type of system it is? It is going to be type 2 system. Now, what you should know for a type 2 system? Okay, what you should know for a type 2 system? Steady state error, okay, for unit step input will be anyway 0. Steady state error for unit ramp input also will be 0. Also 0. Steady state error for, it will give a finite error for unit parabolic input, and that will be given by 1 upon Ka. The error is 1 upon Ka, Ka being the acceleration error coefficient. Okay, now what is the Ka value here? Ka is given by the formula limit s tending to 0, s square multiplied by Gs. Okay, so limit s tending to 0, s square multiplied by Gs will be 5s plus 1 upon s square into s plus 3. So this s square factor will get cancelled and you will have the answer 5 into 1 divided by 3. So this Ka is 5 by 3, number 1 point. Okay, Ka is 5 by 3. Now see the input. Okay, what is the input? Okay, this is 1. Okay, 1 means step, unit step. Okay, then unit ramp. Okay, unit ramp is known as 2. So this is twice of unit ramp. I should put it this way. Unit ramp input is defined as T. Then similarly, this is the answer for unit parabolic input. Okay, you have to write down this like this, because what is unit parabolic input definition, dear? Unit parabolic input is T square by 2. Unit parabolic input is actually T square by 2. Okay, not T square. So you should write this as 10 into T square by 2. That means 10 times unit parabolic input. Okay. Now, what is the steady state error? Okay, there are 3 different elements of input, but because of step and because of ramp, the error is 0. But because of unit parabolic, the error is 1 by Ka. 10 times unit parabolic, see what is the error? Difference between input and output. If input is 10 times, output also 10 times. Linearity, linear system. Okay, if input output both are 10 times, error also 10 times. Okay, so 10 times 1 by Ka. Okay, 10 times 1 by K. Now reciprocal of Ka will be 3 by 5. Ka was 5 by 3. Reciprocal will be, answer is 6. Answer is 100% 6. Okay, answer is 100% 6. I think there is some typo error or something. I'll correct this. I'll make this answer as 6. Correct answer is option number A. Okay, correct answer being option number A. No, Satyam, it is not coming up to be 0.2. You can check that clearly. No, it is not 0.2. Okay, right. Next question. Please have a look into the next question here. A unity feedback system has the forward part transfer function given. Okay, the value of K to yield a 10% error in steady state. 10% error in steady state. I'll complete the question. Due to unit step input. due to unit step input. Yeah, please complete this. Yeah, if your inclination is there towards research, then yes, it is a good option, Winterchild. But you know, to choose that, you should be really interested in that field, then it is absolutely good. Okay, yeah. The value of k to yield a steady state error, 10% steady state error due to unit step input. Now see, okay, again the system mentioned is unity feedback, okay, and then if I look into GS, what is the type of GS here? Number of poles of GS at origin, there is no S power n term, it is like S power 0. Okay, so it is type 0 system. Now for type 0 system, what is the steady state error to unit step input? Steady state error for unit step input is given by the formula 1 upon 1 plus Kp. Okay, if I ask you due to ramp, if I ask you due to parabolic, unit ramp, unit parabolic, the error is infinity for a type 0 system. For a type 0 system. Okay, steady state error to ramp, steady state error to parabolic. Okay, now what is Kp given by? Okay, what is Kp given by? Kp is given by the formula limit s tending to 0 of Gs. Limit s tending to 0 of Gs. So when you put s tending to 0 here, what do you get? K into 12 upon 14 into 18. Okay, K into 12 divided by 14 into 18. Correct? This is what I will get. So after simplification, what it should be coming up? Okay, I've put the s tending to 0 already. And this is the result after putting s tending to 0. Okay, this can be cancelled as 2 by 3, right? And 2 you can cancel here with 7 into 3, 21. K by 21 is, I think, left out here. Okay, now it is already given. What is the value of K to yield a 10% error? 10% error means 0.1 in the absolute sense, 10 by 100. 0.1 is the steady state error given, 0.1. That means what should be 1 plus Kp first of all? 1 plus Kp is 1 upon 0.1, that is 10. So what is the value of Kp is 9. Okay, so this value has to be compared with 9 and K is then equal to 21 into 9, which is 189. Which is 189. Correct answer, Sai Vikas, 189. 189 is what is the correct answer. Okay. Okay, next question. Let's move ahead to the next question. Yes, Winterchild, correct, 189. Okay. Now, a unity feedback closed loop system has a plant GS and a PD controller GCS in the forward path. Okay, the PD controller GCS containing TP, the TP plus TP into TDS. You can open this like this, na? TP plus TP TDS. Okay, right. So this is the proportional part. This is the derivative part. Okay, how do you normally write down the PD controller gain? You normally write down controller gain as Kp plus, write down, na? Okay, a constant part and the S term. Okay. Okay, TP plus TD into TP into TDS. So anyways, what does the question means that in the feed forward path, okay, and unity feedback is mentioned. Okay, so what is there in the feed forward path? A plant is there having the gain 1 by S square. It is to be controlled by a PD controller. The gain of the PD controller GCS is given as TP plus TP TDS. This will be connected in unity negative feedback manner. Okay, this is what is given. Which of the following statement is not true? Which of the following statement is not true? The system is always stable. Now have a look into it. See, this was 1 by S square actually. The system is always stable. Okay, let me write down the characteristic equation. Let me see for stability, do I need to go to Routh-Hurwitz? See, usually if I don't give any data, The intent of the PD controller is always to make the system stable, because PD controller does what? It introduces what? A zero in the transfer function, okay, which will bend the root locus towards LHP, improving the stability. That is a general thing. But with data given, we have to verify. Now, what is the characteristic equation? 1 plus overall forward path gain, HS is still 1, so 1 plus 1 by S square into TP plus TP TDS equal to 0. So, when I simplify this, I can write this as S square plus writing down this term first, TP TDS plus TP equal to 0, right? Where TP and TD are positive adjustable parameters. You can adjust, but they are positive. Okay, TP and TD are both positive. Okay, now for second order system, tell me, do you need to go to the Routh-Hurwitz? For second order system, do you need to go to Routh-Hurwitz? Not required. For second order system, if all coefficients are of same sign, then the system will be stable. TP is positive, TP and TD both are positive. The product of positive is positive. Okay, all coefficients, second order system, it is simply second order system. If it was higher order, then you go for RH. Okay, so second order system, RH, Routh-Hurwitz, not required. Please note that. Okay, now all coefficients are of same sign is what is required for second order system. If all coefficients are of same sign, the system will be 100% stable. Both the roots will be in the LHP. The system will be 100% stable. Okay, the system is stable, true. But what I want a not true option, false option. The system may have damped oscillation. Yes. See, what is damped oscillation? Damped oscillation comes for zeta between 0 to 1, underdamped system. Underdamped system. So zeta, now what is zeta? Now see, what is zeta? You have omega n square equal to TP. This is omega n square, and 2 zeta omega n equal to the central term TP TD. Okay, so what is 2 zeta? Omega n is root TP, is TP TD. Now see, what is the value of zeta? Zeta can be written as 1 root TP can get cancelled, 1 by 2 into TD divided TD into root TP into TD. Yeah, so because they are adjustable parameters, zeta may be less than 1, possible. Okay, so for zeta between 0 to 1, is this possible or not? Yes. And that is why they are telling the system may have. They are not telling system will have. If I say a system will confirm have damped oscillation, okay, then that is not generally correct. Okay, but yeah, there can be some value of TPDD for which this is possible. Okay, so the system may have damped oscillation, correct. The system amplifies the noise. Now PD controller, the very important, one of the very important effect of PD controller, it reduces the rise time, increasing the bandwidth. Rise time decreases and bandwidth increases, and whenever bandwidth of a system increases, okay, it will allow more noise, because noise is what? A high frequency term. Bandwidth increasing means it is allowing more of high frequency terms. Okay, so it amplifies the noise, is also a true thing. Okay, is also a true thing. It amplifies the noise because bandwidth increases. Bandwidth increases, correct? The system has zero steady state error for unit parabolic input. See, what is the type of the system? If you overall see, if you just see here only, what is going to be the type? Okay, what is the overall open loop gain? Final open loop transfer function or final forward path gain? Anyways, unity feedback is there. Na? Final forward path gain, when these two are multiplied in cascade, you will see like this: TP plus TP TDS divided by S square. Okay, so it is type 2 very clearly. Okay, and for type 2, what we just revised in the earlier questions also. Okay, type 2, steady state error for unit parabolic. Okay, steady state error for unit parabolic is how much? 1 by Ka, where it is not equal to 0. This is wrong. Okay, this is the false option. Okay, option number D. They are not asking the error. If they ask error, you have to calculate Ka. Okay, what is Ka? If you simplify, you will get limit S tending to 0, S square into GS. Okay, so when you multiply S square cancel, S tending to 0, only TP will be left, and the error is 1 by TP. the error will be 1 by TP. Okay. Error will be 1 by TP. Correct answer is actually D here. The correct answer is actually D here. Okay, fine. The correct answer will be D here. Which is not true. Rest all are true. Okay. Yeah. Next question. Now comment on stability and determine the number of LHP, RHP and J omega axis roots for the given characteristic equation. Now, because it is higher order system, okay, then you have to go for what? Then you have to definitely go for the Routh-Hurwitz criteria. Go for Routh-Hurwitz criteria. Okay. You have to go for Routh-Hurwitz criteria. Okay. See, third point I have taken as a general effect. See, what is there in the third point? If you have the doubts with respect to the third point, what is the analysis you actually need to do? Okay. See, what is the analysis you need to do? The analysis is, okay, the rise time. Okay. Rise time is given by what formula? Pi minus phi by omega d. Okay. Pi minus phi. Phi is how much? Cos inverse zeta divided by omega d, omega n, under root 1 minus zeta square. Okay. Under root 1 minus zeta square. Now, what is seen in case of rise time? I'm just explaining that. What is seen in case of rise time when you look into the system with and without the controller? Okay, with and without the controller, what is normally obtained at rise time, okay, is going to increase. Okay, and that is the reason I am telling bandwidth is decreased. So that detailed derivation I am not going, okay, but everything, what is omega and what is zeta, that has been calculated in front of you. You can substitute and you can analyze. Okay, that is the point I wanted to say here. Okay. Yes, humble man will plan the marks versus rank analysis video. Yeah. Okay, come up here, guys. So what is there? Stability and determine the number of LHP, RHP. Okay, so for that I'll have to go for the Routh-Hurwitz criteria now, because it is a higher order system. Okay, I'll start with the Routh array here only, starting with the first two rows. Okay, of s power 5 and s power 4. Alternate terms in s power 5, which are 1, 2 and 5. Odd terms. Okay, 1 and 2 and 5. Then the remaining alternate terms, the s power 4, the even coefficient term in the next row. Okay, that is 1.5 and then 4 and then 10. Okay, 1.5 and 4 and 10. Now s power 3. How do you solve for s power 3? You will cross multiply. Okay, reverse cross multiply, like reverse of determinant. 1.5 into 2 minus 4, okay, which is minus 1 divided by 1.5. Minus 1 is divided by 1.5. Next, okay, first column, you remember Routh-Hurwitz, na? Okay, first column will remain same. Second column you have to choose as the next one. Okay, so if this is the first column, how cross multiplication? 1.5 into 5, 7.5 minus 10. Okay, 7.5 minus 10 minus 2.5 divided by, see, divided by always the first element of the above row. First element of the above row. Now, when you go for the next element, see, I told you first column will be fixed. Okay, you have to just change the next column. So, what is the next column? Not there means 0. Okay, so this element will be 0. Any column 0, determinant 0. So, basically remember, last element of a row will always be 0 only, na? Last element always be 0 because there are no elements on the next column seen. Okay, now one thing is your choice. You can make the calculation simple actually by multiplying any row by any constant value, any positive constant value. So rather than dealing with the number 1 by 1.5, 2.5 upon 1.5, multiply by 1.5. Okay, multiply here by 1.5. So when you multiply here by 1.5, you will get the row as minus 1, minus 2.5 and 0 remains 0. That makes it simple. Now going forward, okay, going forward, don't consider this row. This has been modified and consider the s power 3 row. Now consider the s power 3 row. Okay, what is there in the s power 3 row? Now you see. Okay, minus 4. Okay, minus of minus 2.5 into 1.5 will be how much? 3.75. So minus 4 plus 3.75 minus 0.25 divided by minus 1 divided by the first element of above row. Okay, so divided by minus 1. I'll simplify and write down. Okay, then now you see minus 1 into 10 minus 0. That you can remove. Okay, so what is there? Minus 1 into 10 divided by minus 1. That is simply 10. And last element anyway is 0. So here minus minus cancel. What will I write down here? 0.25. I have written here 0.25, corrected. Now S power 1 row, next row, again 0.25 into minus 2.5 minus minus plus 10 divided by 0.25. Okay, how much is the net calculated value? I will write down here directly how much I am getting. Okay, yeah, and then that is minus and minus, that will become plus 10. Okay, so 9.375 actually. Okay, 9.375 divide by 0.25. Divide by 0.25, 37.5. Final value 37.5. Okay, now you see this will be 0 because you see the next column entry as 0. Last element anyway is 0. Now S raised to the power 0. Okay, 37.5 into 10 divided by 37.5. 10 will be the last element. This is again 0. Entries are 0. Last element anyway is going to be 0. Okay, this is what is the Routh table. Okay, now if you see the first column, how many sign changes are seen in the first column? Positive, positive, okay, then minus 1, okay, positive to negative, then immediately negative to positive, positive to negative, negative to positive, immediately happened, na? Positive to negative, negative to positive. Okay, so how many RHP roots? First thing is RHP roots. Okay, number of RHP roots is given by what? Is given by number of sign changes. Number of sign changes where? Number of sign changes in the first column of the Routh array. Given by the number of sign changes in the first column of the Routh array, right? Okay, now how many sign changes in the first column of the Routh array? Okay, positive to negative, negative to positive. So there are two sign changes. You don't have to count negative numbers, you have to count sign changes. So there are two sign changes. Okay, so this is RHP roots. Okay, now J omega roots, how do you determine? Now I'll tell you again. J omega roots are only possible with auxiliary equation. Auxiliary equation comes in row of 0. So don't think about J omega axis roots. Because there is no ROZ here. ROZ means row of 0. Okay, just blindly put the point. If you have no row of 0, you will not have auxiliary equation. You will not have any J omega axis roots. Okay, so you can simply say it is 0. So how many LHP roots? What is the degree of the equation? It's a fifth, 5 degree. Okay, degree is 5. 5 minus how much? 2. Okay, 5 minus 2, there is nothing on J omega. Okay, so the remaining 3 is on LHP. Okay, so LHP 3, RHP 2 and nothing on J omega. This is how the roots are classified. Okay, commenting on stability, system is stable or unstable? Unstable, because you have RHP roots. Even a single RHP root system is unstable. Got it? Even if you have a single RHP root system is unstable. Correct. Next one. Now see, a question where actually I'll introduce ROZ. The most important case and most expected case from Routh-Hurwitz is the one which has row of 0. Okay, and I'll tell you some relevant shortcuts also around this. Sorry, not this one, this one. Have a look into it. First, let us draw the Routh array. Okay, let us draw the Routh array. What is the characteristic equation given? I'll draw the Routh array here directly with the S power 6 and S power 5 row. What is the S power 6 alternate terms? Even power terms, S power 6, S power 4, S power 2, S power 0. Okay, 1, 5, 2 minus 8. 1, 5, 2 minus 8. Then S power 5, 1, 3 minus 4. 1 and 3 and minus 4. This is 1, this is 3, this is minus 4, this is 0. 1 and 3 and minus 4 and 0. Okay. 1 and 3 and minus 4 and 0. S raised to the power 4. Okay. S power 4. How much it is going to be? 5 minus 3. Okay. 2. 2 by 1. That is 2. Then 2 minus minus 4. 6. 6 by 1. 1 into minus 8 minus 0. Okay. So 1 into minus 8 upon 1 minus 8. And then again a 0. Okay. Then S raised to the power 3. What is there in the S power 3 row? Okay, so 2, 3, 6, minus 6, 0. 2 into minus 4, minus 8, minus of minus 8, again 0. Now this will be 0 because next column is 0 and last element anyway is 0. And that is what I mean by a row of zeros. You see here. Okay, this is what I mean by a ROZ. This is what I mean by ROZ, known as row of zeros. Now, what do you do in case of row of 0? We form an auxiliary equation. Let me just brief out the quick steps for you. I've got it ready for you. Okay, first step, you form the auxiliary equation. Okay, by using the coefficients of the equation above the row of 0. Okay, you use the equation above the row of 0 and then differentiate the auxiliary equation. Now, let me first make the auxiliary equation. So, I am telling you auxiliary equation is made by using the coefficients of the row above the row of 0. So, I go here, okay, to this row which is above the row of 0. Okay, and then which is above the row of 0 and I make auxiliary equation. Now, what is that auxiliary equation? See here. See what is going to be this auxiliary equation? Okay, what is this equation? S power 4, coefficient 2s power 4 and every coefficient is an alternate term coefficient. Next will be 6 which is coefficient of x square. Next minus 8 which is of s power 0, s power 0 is 1, I can remove. This is the auxiliary equation. Okay, then what I told you, differentiate the auxiliary equation. Okay, differentiate d by ds. Okay, d by ds. So when you differentiate, 4 to this becomes 8s cube plus 6 to 12s equal to 0. Then after differentiating, what I told you? Yeah. Replace the row of 0 by the coefficients of the above equation. The above equation means differentiated equation. Okay, which is again in s power 3. So this was the row of 0. I will write down modified s power 3 row. Okay, now see, what is the modified s power 3 row? I'll write down here as well. Modified s power 3 row. Now s power 3 coefficient 8, alternate term 12. 8 and 12 are the two coefficients that you can fit in here. 8 and 12. Rest, what is not there means 0. Okay. Now continue with the Routh-Hurwitz again. Now continue with the Routh-Hurwitz. So s square. Okay. Now s power 3, this is gone. Okay. You have to consider the modified s power 3 row which is written here. Okay. So you don't have to consider this one. S power 3, s power 4. 8 into 6, 48 minus 24. 24 by 8, 3. 8 into minus 8, this side 0. 8 into minus 8 upon 8. So only minus 8 is left. This is again 0 because the next top column is 0. Last element anyway is 0. So I have completed s power 2 row. Now s power 1 row. Now s power 1 row. What is there in the s power 1 row? You see here, s power 1 row is 3 into 12, 36 minus of minus 64, 100. 100 by 3. Okay, 100 by 3. Now this is 0 because next column is 0. This will also be 0. Next column is 0. And last element anyway 0. So one last row s power 0. 100 by 3 into minus 8. Divide by 100 by 3 minus 8. Okay, 0. Because again next 0. This is also 0, 0. My Routh-Hurwitz complete up to the s power 0 row. My Routh-Hurwitz is complete up to the s raised to the power 0 row. Okay. My Routh-Hurwitz is clearly complete up to this point. Okay. Up to the s power 0 row. Now, how to comment on how many LHP and RHP roots? RHP roots are still equal to 1. RHP roots are still equal to 1. Now, see. RHP roots corresponds to sign changes in first column. There is no change in that theory. Correspond to sign changes in first column. Okay. How many sign changes in first column? Okay, if you see from the top to bottom, plus, 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 minus. So at the end, you go from plus to minus. This is one sign change. Only at the end, you go from plus to minus, and that is what is a sign change for you. Okay, so how many sign change in the first column? Only one. So only one RHP root. Okay, but I want everything, number of, actually the question number of poles in the LHP. I have written the questions in LHP. How many you get in LHP? But because there is a row of 0, there is a possibility of j omega roots. Okay, so you have to comment on this. How many j omega roots? Okay, and then how many LHP roots? Okay, if there was no j omega roots, then I will tell you 6th order equation, 6 minus 1 RHP, 5 in LHP, but there may be j omega axis roots. Okay, there may be j omega axis roots. How do you comment on j omega axis roots? Okay, how do you comment on j omega roots? Okay, now method number 1, okay, which you will not do actually, but I am just telling you for this question, solve auxiliary equation. Okay, we cannot solve it every time, but just understand, this is one possibility I am telling. What is that auxiliary equation? Auxiliary equation 2s power 4 plus 6s square minus 8 equal to 0. Or first let me divide by 2, so s power 4 plus 3s square minus 4 equal to 0. So what do you have? S square, how will I factorize? I can factorize as s square plus 4, s square minus 1 equal to 0. So what are the values of s square? S square equal to minus 4 and plus 1. So what is s? Under root of minus 4 plus minus j2. Under root of 1 plus minus 1. These are the j omega roots. These are the j omega roots. Okay. So there is one pair of j omega roots. There is one pair of j omega roots. Right? Right. Right. There is one pair of j omega roots which is in front of you. Okay, that is plus minus j2. That is plus minus j2. Okay. Or another simple way. Another simple way. Okay. Method number 2. For auxiliary equation. Now see, the point is, I'll tell you some basics behind this and then we'll complete this question. See, what I told you, row of 0 will always be, see, what is a row of 0? We got in s power 3 row. Row of 0 is always in odd power row. Number 2, roots of auxiliary equation will always satisfy the characteristic equation. That is why I am solving auxiliary equation. Okay, now this is the important point. Come up here. Okay, what is the second point? I will repeat this way. What are the roots of auxiliary equation you got? Plus minus j2, plus minus 1. You take any of them. You take any of them. Okay, if you have time, not required. I am giving you an option. You take any of them. You put down the value here. Okay, it will satisfy the characteristic equation. Every root of auxiliary equation will satisfy characteristic equation. Dear, auxiliary equation is just a factor of characteristic equation, nothing more. Okay, nothing more. So that is what I wanted to say here. Now for auxiliary equation, what will happen? So yeah, that's what the third important point. This is the most important point. The presence of row of zeros, okay, may lead to one or more of the following possibilities or following condition. There exists at least one pair of imaginary roots. There is at least one. So see, first possibility is there is a pair of imaginary roots, plus jy minus jy. Okay, or there is at least one pair of real roots having equal magnitude but opposite sign. See here, minus x plus x, equal magnitude but opposite sign. Okay, and third condition, there are two pairs of complex conjugate roots located symmetrically with respect to imaginary axis. That means if this is x plus jy, okay, this is x minus jy, and symmetrically on the left as well, this is minus x plus jy and this will be minus x minus jy, a quadrature of pole. Okay, this is first possibility. Okay, this is the second possibility and this is the third possibility. Okay, what is the overall condition? That in either case you see roots of auxiliary equation, okay, are always symmetric. Are always symmetric with respect to origin. You see here, okay, plus y minus y, plus above minus same above. Okay, minus x left plus x right, symmetry with respect to origin. And even all of these, if you find out the distances from origin, all of them will have the distance equal to under root x square plus y square. The roots are always symmetric with respect to origin for auxiliary equation. That is very important point you should note. That is the reason, I can say one more point. For roots of auxiliary equation are symmetric with reference to origin. You see here in the first condition, In the first condition, how many roots to the left, how many roots to the right? Nothing on the left, nothing on the right, 0. In the second condition, how many left and how many right? 1 left, 1 right. In the third condition, how many left, how many right? 2 left, 2 right. Okay, that means for auxiliary equation, okay, the number of L roots and the number of R roots are always equal. For auxiliary equation, the number of L roots and number of R roots, L means LHP, R means RHP, are always equal. So, what I was telling you, if I go to that second case, for auxiliary equation, number of L and number of R roots are equal. Okay, but anytime number of R roots are equal to what? Okay, number of RHP roots are number of sign changes. Number of sign changes in the first column. Okay, but you are finding the roots of only auxiliary equation. So, number of sign changes has to be seen only below the auxiliary equation. So, come to the table. Come to the Routh table with me. This is my auxiliary equation. Nah? Okay, so below this you see. Below this you see how many sign changes? Plus, 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 minus, 1 sign change. 1 sign change. Only in the auxiliary equation and below part. Got my point? Only in the auxiliary equation and below part. Okay. So, here what is the value of R is equal to 1. Okay, so how many value of L? L is also equal to R equal to 1. So, now tell me how many j omega roots? How many j omega roots? Now you tell me. J omega roots. Auxiliary equation is which order? Auxiliary equation is 4th order. Auxiliary equation is 4th order. Out of the 4 roots, okay, 1 is on the left, 1 is on the right. Okay, out of the 4, 1 is on the left, 1 is on the right. Remaining where? If nothing is on the left or on the right, it is on the boundary, j omega axis. So, how many j omega roots? That is actually equal to 2. Right? How many j omega axis roots? 2. Now, the final answer. Final answer for characteristic equation. Okay, how many RHP roots? For the entire characteristic equation, how many RHP roots? That is written already. That is written already 1. Okay. How many j omega roots? 2. Okay. How many LHP? This was my question. So, total order of the equation given is 6, out of which 1 is on the right, 2 on the j omega, remaining 3 is on the LHP. This is the answer. Remaining 3 is on the LHP. Remaining 3, option number C. Correct answer is option number C. Okay. Let me know if there is any confusion here by chance. Consider a unity feedback system with the forward part transfer function. Given the system will oscillate for what value of k? The system will oscillate for what value of k? Okay, now oscillatory means marginally stable. Oscillatory system is also marginally stable system. Okay, the boundary between stability and instability. See, if you are only finding Vijay, see what I told you here, I am finding the number of RHP roots of auxiliary equation. That is why the sign changes are to be seen below auxiliary equation. If you are finding the total number of RHP roots for the given question, then you have to see the overall sign changes from top to bottom. Okay, but why I am observing auxiliary equation separately? Total RHP roots is obtained directly only, but why I am analyzing auxiliary equation? Just to know whether there are j omega roots. So, see, what do I got to know? J omega 2 roots, 1 LHP, 1 RHP. So, when I solve the auxiliary equation, every time you don't have to solve. Okay, every time you don't have to solve. This is the method that you have to prefer. This is the direct shortcut. You don't have to solve the auxiliary equation. Okay, but yeah, even when I solved it, what did I show you? Even when I solved it, what did I show you? Okay, that You see, I'll just draw this. Okay, what I have got here. Okay, S equal to plus minus 1. Okay, this is one condition of roots. Minus 1 and plus 1 and plus minus J2. Okay, this is J2 minus J2. J2 minus J2. Got my point? This is same. Plus J2 minus J2. Okay, so that is what? A pair of imaginary roots, one LHP, one RHP. One LHP, one RHP, 2 on J omega. That we are directly able to find without solving the auxiliary equation. Yeah. So I was here onto the next question, going back there. Right. The system will oscillate, means marginally stable. Okay, first of all, what is the characteristic equation? 1 plus GSHS, unity feedback is there. 1 plus GS, that is K by S plus 15, S plus 27, S plus 38 equal to 0. So when you solve it, S cube will come plus 15 and 27, 42, 42 plus 38, 80 S square. You have to just, otherwise you can multiply term by term. Okay, 42, 8, 50. Yeah. Next term is going to be how much? I'll write down the next term for you directly. Okay, otherwise you can multiply the factors. Next term is pairwise product, 15 into 27. If you know the cubic equations calculations quickly, 15 into 38 plus 27 into 38. Okay, 2001. The next factor here will be 2001S, and the last one will be product of these three numbers. So that I will multiply here separately. 15 into 27 is multiplied by 38, and that is 15390 equal to 0. Okay. System will oscillate. Okay, for what value of K? System will be marginally stable for what value of K? Okay, now cubic equation shortcut, AS cube plus BS square plus CS plus D equal to 0. This is the general cubic equation. Okay, direct shortcut for cubic equation. This shortcut has come up nothing from RH only. No other way, from RH only, but cubic equation cases are common. Even in GATE 2026, there was a question out of cubic. What you can directly use? Product of inner, product of outer. Inner means B into C, outer means A into D. If BC minus AD is positive, system will be stable. If BC minus AD is negative or is 0, first let me kick the boundary, the system will be marginally stable. And if BC minus AD becomes negative, then the system is unstable. Okay, so the question is system marginally stable. Stable means BC minus AD has to be equated to 0. Okay, sorry, here one factor I missed. Plus K will also come. Okay, this much plus K equal to 0. So D factor. Okay, so that means what I have to solve here is BC equal to AD, and BC means 80 into 2007 is equal to A into D. A is 1 here, so only D left, that is 15390 plus K. Okay, so solving this, you will get the value of K. Solving this, you will get the value of K. How much I am getting? Let me just write down here. (2007) or 2001? 2007 it was, or 2001 it was? I think I've written wrong. I calculated as 2001. I'll recheck it. 15 into 27, 15 into 38, and 27 into 38. 2001 it was, sorry. Okay, 2001 it was. I'll correct that. And then minus 15,390. 144690. Option number C. Okay, 144690. Okay, this is 2001 actually. Okay, here also I'll do that correction. This was 2001. Okay, so 144690. Option number C. 144690. Option number C. Correct, Samuka. Okay, 144690. Option number C is what is the correct answer. Okay. No. Anyways, moving ahead to the next question. Consider the open loop transfer function given below. What is the correct polar plot for the above system function? Now, what is the quick way of commenting to the polar plot? Okay, first let me introduce that shortcut for you. I have also covered this in the earlier detailed videos that I have taken. Okay, so shortcut for sketching polar plot for p greater than equal to z. Now, what is p and z? Suppose some open loop transfer function GSHS is given to you. Okay, k 1 plus st1 1 plus st2 divided by s power n 1 plus sta 1 plus stp, etc. Okay, what is n here? Number of poles at origin, open loop poles, poles of GSHS. What is P? P means total number of poles. Total means including origin and other than origin. And Z is total number of zeros. Okay, so this shortcut that I am telling is for P greater than Z, P greater than equal to Z. Okay, which usually is given to you in the question. Now, polar plot, especially MCQ question. Okay, other than MCQ also you can still draw a rough curve, but for MCQ this is like very useful. Okay, the starting and diving angle. Starting, okay, this is theta st. Starting means for omega tending to 0, and it is theta d. Diving or terminating, I call it as diving, for omega tending to infinity. Diving means what? Dive into origin, because for omega tending to infinity and for p greater than z, that means denominator degree more than numerator degree, okay, always at omega tending to infinity the magnitude is 0, and magnitude 0 is origin, so you dive into origin. Okay, that is the way I write, dive into origin. Okay, the starting angle will be given by minus 90 degree into n, and diving angle will be given by minus 90 degree into p minus z. Okay, now if there is a 0 in the RHP, I mean by chance minimum phase cases are given, for a 0 in RHP, the starting angle will change. If I am not changing theta, if I have not written theta d, means it will not change. Only the starting angle formula will change, minus 90 degree into n plus 180, and if there is a pole in RHP, then minus 180 degree. Okay, minus 180 degree. Let me simply use these points here. Okay, what is the type of condition given? Okay, now see here. How many poles at origin? N equal to 1. Okay, how many total number of poles? 2, 1, 2. How many zeros? Numerator 1 term. Okay, but remember you have a RHP 0. You have a RHP 0. So what is the starting formula you will use? Theta st minus 90 degree into n, and because of RHP 0 plus 180, otherwise we only use minus 90 into n. Okay, now what is the value of n? N is equal to 1, minus 90 plus 180 will be plus 90. Now what is plus 90? Plus 90 means positive y-axis. Plus 90 is along positive y-axis. Then what is the theta d? Theta d is minus 90 into p minus z. That is not affected by RHP pole or 0. Okay, minus 90 into p minus z means into total number of 2, total number of 1 is 1. So this is minus 90. What is minus 90? Minus 90 means negative y-axis. Okay, so a polar plot should be starting towards positive y-axis and diving. D means what? Diving into origin. So when you touch the origin, you should be touching along negative y-axis. Okay, you should be touching along negative y-axis. Now you see here, okay, is this much enough, or maybe one more calculation might be required here. Now see, what is left in front of me? Option number A or B. Okay, option number A or B. Okay, because, C, I think a typo error. Forget, C is some typo error. It has to be some plot given. But yeah, okay, but yeah, what is important here is, okay, what is important here is if you are able to see this, okay, if you are able to see this, okay, when you dive into origin, okay, what is the angle? Okay, you are diving along positive x-axis, that is 0 degree. Positive x-axis means 0 degree. Okay, positive x-axis means 0 degree. Okay, so that means this cannot be the correct answer. So out of these two, what is the option left? A or B? Because in A or B, if you see, the diving is along negative y-axis. Okay, but which out of A or B correct? I mean that quadrant. That also I'll tell you very quickly. Many times quadrant means Okay, many times quadrant means one more method actually to find the quadrant of the plot is convert to S equal to j omega, convert to the Cartesian form and then get the answer. But that will be little time taking. I'll tell you very simple thing here. That also can be done, but I'll tell you one simple thing here. Oh, great to see you here, Ashu sir here. Okay, so yeah, thank you sir for your lovely message and hope you are also doing very good. Okay, great to have you in the session, especially control systems. Okay, we have had a lot of discussion for this subject to make it together. Okay, so nice to hear from you, sir. Okay, guys, yeah. So yeah, moving ahead now. So what is there? If you write down the angle expression, I am telling you either the the Cartesian form or the phase form. See, what is going to be angle Gj omega? Okay, what is going to be the angle Gj omega? I am writing down directly. Okay, what is the angle here? Be very careful. Tan inverse omega upon -1. Second quadrant, you cannot directly take minus outside. Tan inverse omega upon -1. This is pure imaginary, j omega, 90 degree. Then minus j omega plus 1. So that is tan inverse omega. Okay, tan inverse y upon minus x is further 180 degree minus tan inverse y by x. 180 degree minus tan inverse omega. Then further minus 90 minus tan inverse omega. See dear, actually, whatever starting and diving angle I have written, now this becomes 90 minus 2 tan inverse omega. 90 minus 2 tan inverse omega. Now, whatever starting and diving I have written, that also you can tally. Starting means omega tending to 0. Okay, when omega tending to 0, when omega tending to 0, how much you get? Tan inverse 0 is 0, 90 degree. We got it or not? That is a shortcut I have directly told you. Okay, for MCQ questions it can help you. Okay, but here we have still a confusion between A and B. That is what I am trying to tell you. Now for omega tending to infinity, diving, omega tending to infinity, tan inverse infinity 90, 90 minus twice of 90, minus 90. Will minus 90 come? Yes. Yes, na? Okay. Now, important point is whether it is A or B. Okay, whether it is A or B. What I usually do in such case, even if I take some small omega, even if I say some small omega, suppose omega equal to 0.01, don't use the calculator, but what will be the angle you see? This will be some small angle. If you take omega 0, this is clearly 0, 90 will come. Okay, 90 will come. This is some small angle or not? Okay, suppose some 1 degree, 2 degree, something came up, assume na, the answer will be less than 90 or greater than 90, 90 minus something, 90 minus some positive number. Okay, so what is going to be the angle? The overall angle, okay, will be close to 90 but slightly less than 90. More than 90, less than 90, less than 90. That means if I have to draw the point corresponding to a small omega, that point angle, okay, that point angle, I'll write this clearly. That point angle Gj omega is less than 90, and less than 90 means the point will stop in the first quadrant. Na? Okay, because this was 90 degree, I have to draw this point. It will be close to 90 but less than 90. Okay, so the point has to be in first quadrant. Na? If it was more than 90, then the point will shift to the second quadrant. So now tell me the correct answer. Now tell me the correct answer. The correct answer has to be B in that case. I mean the first quadrant for any omega slightly greater than 0. Okay, the plot will start from the right side. That is option number B. That is option number B. Okay, that is option number B. Yes, right. That is what is going to be option number B. Got my point here? Okay. Otherwise, one more way of telling the quadrant is converting S equal to j omega. Okay, that also is possible, but that is usually, here also that is not lengthy, but usually that Cartesian form will be more lengthy. Rather than, you calculate the phase, that is more easy. That is what I believe. Cartesian form will be little calculative. Easy but calculative. Anyways. Let's see the next thing now. Okay. Yeah, Samukha, correct B answer. Okay. Let us see the next one. Okay. Let us see the next one. Now, have a look into this next question here. Have a look into this next question. The open loop transfer function of a unity feedback Okay, negative feedback system is given to you, k upon s minus 1, s square plus 4s plus 7. The Nyquist contour is in S plane. The Nyquist contour is also shown to you. For k greater than 0, the Nyquist plot in GSHS plane is also shown to you. The system is stable for what range of k? The system is stable for what range of k? The system is stable for what range of k? Okay. So Nyquist contour, okay, which covers the entire RHP, also passing through origin, because there is no GS pole at the origin. Okay, there is no GS pole at origin. Now, from Nyquist plot, I will tell you two simple ways. See, one way is solving through Nyquist plot, which I will tell you. One is more smarter way. I will tell you that also. Okay, but before I give you the hint towards that, let me focus on the Nyquist plot way of this question. See, what you normally want to solve this question through Nyquist plot. Okay, from the Nyquist plot, the number of encirclements of the modified origin minus 1 comma 0, I am just writing the final conclusion. Okay, if you want to have the entire derivation of Nyquist plot, that is also available on the Home Institute YouTube channel. Everything I have explained A to Z of Nyquist plot. Okay, how this formula comes up, what is 0 comma 0 role, what is minus 1 comma 0 role. Okay, we use this formula n equal to p minus z or p plus minus z plus, again, okay, again assuming clockwise Nyquist path, like given in the current question. Okay, like if I go back to the question, see the Nyquist path. See the Nyquist path, okay, which has been given in clockwise sense. See the rotation. Okay, so it is given in the clockwise sense. So assuming clockwise Nyquist contour n equal to p minus z. If it is by chance anti-clockwise path, you will reverse this formula z minus p. Okay, you will reverse the formula z minus p. Now I use a notation plus. What is this plus? Is to use to give you the hint that it is the poles and zeros of the plus side. Plus means right side, positive side. Okay, so what is p plus? P plus is the poles of number of poles of GSHS in the RHP. Okay, because the Nyquist path entirely covers the RHP. Z plus is what? The number of zeros of 1 plus GSHS in the RHP. Zeros of 1 plus GSHS, or you can also call it as roots. 1 plus GSHS equal to 0 means what? Characteristic equation. So roots of GSHS in RHP. What is n? N is the number of encirclements made by the Nyquist plot or the GSHS plot of the modified origin minus 1 comma 0. See, actually when we start discussing Nyquist plot and when we derive the understanding of Nyquist plot, we first actually come up to this representation. Okay, n equal to p minus z. Okay, where n, p and z are the, p plus and z plus are the poles and zeros of GSHS. Poles and zeros of GSHS in RHP. N is the number of encirclements of the actual origin 0, 0. Okay. But then what we do, we actually think about the Nyquist plot of 1 plus GSHS because zeros of GSHS are nothing to do with stability. Now, stability means characteristic equation, means 1 plus GSHS equal to 0. Means 1 plus GSHS equal to 0. Okay, so this is what is the actual data that comes up first. Okay, if you consider poles and zeros of GSHS, okay, then n is the number of encirclements of 0, 0. Okay, again this is for clockwise Nyquist contour, otherwise the formula will reverse as I told you. If it is anti-clockwise Nyquist path, z minus p. Okay, now when you consider the encirclements of minus 1 comma z plus will be the zeros of 1 plus GSHS. Actually p plus is the poles of 1 plus GSHS only, but you try any problem, the poles of GSHS or the poles of 1 plus GSHS will always be the same. Will always be the same. Okay, simple point. Will always be the same. So this is what is the background you have to use. What is given here? A clockwise Nyquist contour has been given. So because the clockwise Nyquist contour has been given, what is the formula I will use? I will use the formula p plus minus z plus. Now what is p plus? The poles of GSHS in the RHP. Okay, poles of GSHS in the RHP. Okay, what are the poles of GSHS? HS is 1. Okay, unity feedback is there, HS is 1. So poles of GSHS means only poles of GS, and that means S equal to 1. And when you solve this, minus 4 plus minus root over B square, okay, that is 16 minus 4 AC, that is going to be 28 divided by 2A. Correct, na? Okay, so these poles are S equal to 1 and minus 4 by 2 minus 2 plus minus J under root of minus 12. So under root minus means J, root 12. I can write 2 root 3, 2 will cancel, minus 2 plus minus j root 3. Anyways, what is important is this one is in RHP. This is the pole of what? Okay, this is the pole of GSHS. Okay, RHP pole of GSHS. Okay, and that means P plus is available here, 1. P plus is available here as 1. Right. So what is the formula I told you? Okay, the clockwise Nyquist contour is given. So n equal to p plus minus z plus. So n is equal to p plus is 1 minus z plus. Now what you actually want? Okay, for stability, okay, the system is stable. What is the system z plus you want? What is z plus? Roots of characteristic equation in RHP. That should be nil, because even if there is one root of characteristic equation, an RHP system cannot be stable. Okay, so z plus will be still 0. Okay, so what is the n you want? You want one encirclement. Okay, you want one encirclement of minus 1 comma 0. Now come up here. Where is minus 1 comma 0? That we cannot decide, because I don't know the value of k. So I don't know what is k by 7. I don't know what is k by 16. So I will have three cases. Number 1, minus 1 comma 0 outside. Okay, if minus 1 comma 0 is totally outside, what is the number of encirclement? Nil. It is not encircled, but this is the case I don't want. Okay, then minus 1 comma 0, second case, minus 1 comma 0 inside this loop. Okay, now inside this loop, what is the number of encirclement? See, very clearly you see one encirclement. Which direction? Clockwise direction. So n equal to 1. Sorry, this was anti-clockwise. 1 anti-clockwise, and anti-clockwise means positive direction. N is 1. That is what I want. Still, I'll show you the third case. In the third case, minus 1 comma 0 can be inside this last loop. Okay, this last loop encircles this point in the clockwise direction. In the clockwise direction. So what is n here? 1 clockwise, and 1 clockwise means minus 1. Okay, so what is the n I want? Okay, I want the n equal to 1, which is happening in the case number 2. Right here. And case number 2, what do you want? Okay, now you see this much of the distance. What is the distance of minus 1 comma 0 is 1, and this distance should be greater than k by 16. 1 should be greater than k by 16, and the same distance 1 should be less than k by 7. Okay, so that will give you the range. Okay, here k is less than 16, here k is greater than 7. So k is between 7 and 16. Okay, k less than 16. From here you will write k greater than 7. K is between 7 to 16. Hope you have got the answer correct. K is between 7 to 16. Option number A. K is between 7 to 16. Option number A. Okay, this is the correct answer, right? Option number A. Now see, this is the Nyquist way of solving it. Now, what is a simple smart way for this question? What is a very simple smart way to handle this question? Okay, a simple and a very smart way to handle this question is, GSHS given. GSHS usually is not given in Nyquist plot question. They give some indirect information on GSHS. Okay, but here GSHS given, so I can form characteristic equation and I can solve the question by Routh-Hurwitz. Nothing, 1 plus GSHS given as k upon s minus 1 into something something, k upon s minus 1, s square plus 4s plus 7. S square plus 4s plus 7 equal to 0. So when I solve this, I'll get s cube, then plus how much? 4s square plus 7s minus s square minus 4s minus 7 and plus k equal to 0. So what do I get is s cube plus 3s square plus 7s minus 4s plus 3s and plus k minus 7 equal to 0. Okay, number 1. Okay, cubic equation again. Okay, cubic equation. So what do you want for stability? Okay, cubic equation. What do you want for stability? I directly told you, na, BC minus AD positive. BC minus AD positive. Shortcut for cubic equation. So what is BC? 3 into 3. Minus AD, A is 1. So AD means K minus 7. Has to be positive. Okay, so I'll write this way. 9 is greater than K minus 7 or K is less than 9 plus 7, 16. Okay, but one more thing. Okay, the Routh-Hurwitz necessary condition. Okay, all coefficients must be of the same sign. That is necessary. This is the sufficient condition plus, so this also requires k minus 7 should be positive, so k greater than 7. K greater than 7, k less than 16. Without using the Nyquist plot. In case if you don't know, then you can directly you do this way as well. K greater than 7, k less than 16. So that is k is between 7 to 16 anyways. K is between 7 to 16, that is done anyways. Okay, let me know if there is any confusion. Okay. Yeah, so that's what you can do here simply. Okay. A simple question here. In the Bode magnitude plot, which one of the following slope would be exhibited at high frequency by a fourth order, okay, fourth order all pole system. Now, if it is fourth order, means how many poles? 4. Okay, and because it is all pole, very clearly meaning no zeros. Okay, now slope at high frequency. Okay, in Bode plot, high frequency slope is given by what formula? In Bode plot, high frequency slope is simply the slope for omega tending to infinity, or also known as final slope. Okay, minus 20 into p minus z. Minus 20 into total number of poles 4, and there are no zeros, so net answer is minus 80 decibel per decade. Minus 80 decibel per decade. Simple question, option number A. Yes, Vijay, correct. Next one. The low frequency asymptote in the Bode plot has a slope of how much? Now, low frequency asymptote. Okay, the slope of low frequency asymptote, also known as initial slope. Okay, also known as initial slope. And what is the initial slope in case of Bode plot? Minus 20 n decibel per decade for n zeros, for n poles at origin. For n poles at origin. For n poles at origin. Okay, so how many poles at origin? Very clearly you can see there are 2 poles at origin. Minus 20 into 2, minus 40. Correct answer here is minus 40. Okay, if there were suppose zeros at origin. Suppose there were zeros at origin. Okay, so for m zeros at origin, what do you do? Okay, then the initial slope is given by, rather than pole, if there are zeros at origin, initial slope will be plus 20 m decibel per decade. Plus 20 m decibel per decade. Okay, so yeah, this one also easy. Next question. Yeah, this is what you can again see. Initial slope positive means zeros at origin. Which of the following transfer function? You can match the option very easily. No need to solve it in a lot of depth. See here, what is the initial slope? 40, very clearly given. Initial slope 40. Initial slope is 40 m. Okay, that, initial slope is to be compared with what? 20 m. 20 m equal to 40. That means m is equal to 2. 2 what? Zeros at origin. So there will be 2 zeros at origin. I think probably every option has zeros at origin, s square. Zeros at origin means s square in the numerator. Every option has that. Okay, every option has that. Now, what is this? Minus 60. What is the change in slope here? Okay, minus plus 40 to minus 60, the change is minus 100. Okay, we have to see the change in the slope. Okay, then we will see whether this pole or zero. First of all, change in slope is negative. So that means this is the pole point, corner frequency due to pole, and minus 100 means minus 25 times. So that means if there is a single pole at a location, it will change the slope by minus 20. If the slope is changed by minus 20 into 5, that means 5 poles. Okay, at the corner frequency. What corner frequency? 10. What corner frequency? Which is equal to the 10. Right. So 1 plus s by 10. Time constant is what? Time constant is reciprocal of corner frequency. Okay, so 1 plus s by 10, that to power 5. Now power 5 is only in option number C. First of all, if you just see 5 poles, that is only in option number C. Option number C, yeah. Correct answer, Samukha, Akash, Harshvardhan, Vijay Kumar, correct. So some questions can be visually solved as well, right? This is visually completed only, nothing so great there. Okay, next one. Yeah, for Bode plot of a transfer function is given below. What is the steady state error corresponding to ramp input? Okay, now why specifically ramp input? Because you see, one more thing I will mention here. I will assume that the system is in unity feedback. That clear assumption I'll make here. Okay, the Bode plot for the open loop transfer function, this transfer function is open loop transfer function and unity feedback is given. The steady state error corresponding to ramp input. Now you see here, what is the initial slope? Minus 20. Initial slope is minus 20n. Negative means poles at origin. So I'll compare with minus 20n. So what is the value of n? N equal to 1 pole. N is how much? N is 1 pole at origin. Okay, n equal to 1 pole at origin for GS, that and because for type 1, what is the error due to step? 0. Okay, steady state error. Input 0, 1 by kV. For parabolic input, infinity. This is the data we need to know for a type 1 system. Okay, so question is on ramp input. So steady state error is given by 1 upon kV. Okay, 1 upon kV means 1 upon k. Okay, now if kV equal to k of standard form. Standard form means time constant form. Okay, standard form means time constant form. Now, okay, what is the k? Okay, for standard form, for the time constant form, I always use a initial part formula. Initial part formula. What is the initial part formula for Bode plot? Very helpful in many questions. Is given by poles at origin minus 20n, okay, log omega, minus 20n log omega plus 20 log k. Now I'll tell you, if there was zeros at origin, you can replace it by plus 20m. Okay, only initial slope will change. Minus 20n log omega plus 20 log k. Now you can see here, what is the meaning of initial part? Initial part means the part up to the first corner frequency. Okay, up to the first slope change point. Okay, so that is up to omega 1. Okay, so anywhere, okay, this any portion of this line is defined by this equation. Okay, so I will use what condition? I will use the magnitude equal to 32. I'm using this point. Omega is given as 0.1. So 32 is minus 20 into n. N is 1 here. Minus 20 into log omega. What is the omega at this point? 0.1 plus 20 log k. Okay, log 0.1 is minus 1. So that will become plus 20. Minus 20 into minus 1 is 20 plus 20 log k. First of all, what is the value of log k from here? 12 by 20, that is going to be 0.6. K will be 10 raised to the power 0.6. Okay, and k will approximately 4. 20 log k is 12, so it should be 4, approximately 4. Okay, k equal to 4. So the answer 1 by 4. Okay, that is 0.25. Option number C, 0.25. This is what is the correct answer. Next question. The open loop transfer function of a system is given by GSHS equal to 100 s plus 100 upon s plus 10. 100 s plus 100 upon s plus 10. In the straight line approximation of the Bode plot, mod gj omega hj omega at omega equal to 100 radian per second are what? Okay, what is the magnitude? Of course, in decibel at omega equal to 100. Now you see, I'll start with a quick sketch of the Bode plot. Okay, before I do that, see, let me do some basic calculations here. What is the GSHS given to me? Okay, 100 into, converting to the standard form, time constant form. Okay, so I'll take 100 outside, 1 plus s by 100 divided by s into 10 outside, 1 plus s by 10. Okay, so this is how much? 100 into 10, 1000. 110 got cancelled. 1000, 1 plus s by 100 is divided by s, 1 plus s by 10. 1 plus s by 10. Okay. Okay, so now if I want to just draw a quick and a rough sketch of the Bode magnitude plot, okay, magnitude means actually 20 log mod gj omega h j omega. In decibel, this is the correct way to write. Okay, they have told mod gj omega h j omega, but options are in decibel. That means which magnitude they are talking? They are talking about 20 log mod gj omega h j omega, not the absolute magnitude. Okay, now how many poles at origin? How many poles at origin? One pole at origin. Okay, there is one pole at origin. Okay, so n equal to 1, so initial slope will be minus 20. Okay, then corner frequency if I write down, okay, if I write down the 0, because of the 0, corner frequency is reciprocal of the time constant. 1 upon 1 by 100 will be 100. Due to the pole, okay, the corner is reciprocal of 1 by 10, which is going to be 10. Okay, the first pole will come. Okay, so let me start. This is the initial part. Initial part is up to the first corner frequency. First corner frequency I have shown you is 10. Then the next corner frequency will be 100. This is the initial slope minus 20 n equal to 1. So initial slope is minus 20 decibel per decade. Okay, this is a pole point. Because this is a pole, slope will again decrease by 20. Okay, so minus 20 minus 40. Okay, we have to find the magnitude at omega equal to 100. That is what? At the next corner frequency. How do I find that? Then only I'll be able to complete this plot as well. So what is important for you here is this line will have slope minus 40. Na? Okay, how much magnitude it will take at omega equal to 100? That's what I want to calculate. Okay, I'll calculate this here. Before that, I will require this magnitude as well. Okay, what is the equation of this line? Initial line minus 20 n log omega, n is 1, minus 20 log omega plus 20 log k. Okay, at omega equal to this 10, at omega equal to 10, how much magnitude? Minus 20 log 10 plus 20 log k. By the way, what is k? K is 1000. K is 1000. 1000 means 10 power 3. Okay, so magnitude is log 10 is 1 minus 20 plus 20. Log 10 power 3 will be 3. 2360 minus 20. This magnitude is actually going to be 40. This is 40. Now I will use the slope of the upcoming line. Okay, this upcoming line will have how much slope? Minus 40. I will draw it neatly, but let me do the calculation. This upcoming line will have a slope of minus 40. Okay, and slope is given by change in magnitude. So with how much magnitude? 40 divided change in log of Bode plot is with respect to log omega. So log of 100, the next frequency that is going to come is 100 and minus log of 10. This is minus 40. Okay, so M2 minus 40 is equal to minus 40 into log 100 will be 2, log 10 is 1. Okay, so M2 minus 40 is minus 40 into minus 40 only. So what is M2? That is actually 0. That is actually 0. That means here, firstly you will change the slope. Okay, you will have to go, draw. So I'll start like this. This is the initial part. Okay. This is magnitude 40 at omega equal to 10. Okay, the initial slope was minus 20. Okay, and now the slope changed by 20. So slope is minus 40. Slope decreased and this slope is minus 40. And at omega equal to 100 when you reach, the magnitude will be 0. Okay, magnitude will be 0. Now this is what? This was a pole, this is a 0 and 0 will increase the slope by 20. So the next slope will be minus 40 plus 20 minus 20. Here also slope change will occur. Okay, so yeah, our answer is 0 dB. What is our concerned answer is option number A, that is 0 dB. Okay. Okay, yeah. Next one. Have a look into this. For the state model x dot equal to ax, where a is 1, 0, 1, 1, what is the state transition matrix? Now, how do you calculate the state transition matrix in general? Okay, the state transition matrix STM phi t defined as e power at is given by inverse Laplace of Si minus a whole inverse. Okay, where this Si minus a whole inverse is also known as the Laplace transform of phi t. Okay, so first we have to target this Si minus a whole inverse. Okay, Si minus a whole inverse. Si minus a whole inverse. Now, please come up and follow with me. Okay, what is the A matrix given to me? 1, 0, 1, 1. 1, 0, 1, 1. Okay, Sachin, I'll request you to better connect with me in Telegram on a personal level so that I can guide you better. Here was what just 1 or 2 minutes if I say will not be beneficial for you. So yeah, just connect with me with my Telegram ID, Rakesh Talreja. You can search me or I'll share you the Telegram ID. There I can guide you in a better way. 65 marks in EE is a good score, reasonably good score this time. Yeah, so what is the Si minus A? This is the A matrix given. Okay, first I will form the Si minus A, then its inverse, then Laplace inverse. What is Si? This is the S into identity matrix minus the A matrix 1, 0, 1, 1. When I subtract these two, what do I get? S minus 1, 0 minus 0 minus 1 and S minus 1. Okay, now what is the Si minus A inverse? Next what I need? Si minus A inverse. Si minus A inverse means adjoint of Si minus A divided by modulus of Si minus A. Okay, adjoint of Si minus A divided by modulus of Si minus A. Okay, now what is the adjoint? Just change the diagonal numbers, which are anyway same here. Exchange the diagonal numbers, and for off diagonal numbers we only change the sign. This is 0, this will become plus 1. Whole divided by determinant. Now determinant means S minus 1 square. This remaining part is 0. Now when you divide S minus 1 square, the first term is 1 upon S minus 1, next is 0, next is 1 S minus 1 square, and last is 1 upon S minus 1. Okay, so this is Si minus A whole inverse, this is phi t, this is known as inverse Laplace of Si minus A whole inverse. Okay, so when you take inverse Laplace, 1 upon S minus 1 is a Laplace transform for e power t, 0 is 0. 1 upon S minus A square, t e power t. 1 upon S minus 1, again e power t. Basic Laplace transform formulas are to be used here. Correct answer will be option. Correct answer will be option number C. Okay. Now I'll tell you very simple way. Okay, very simple way here. One basic observation, phi t is e power at. When you put t equal to 0, you get e power 0, which is 1. 1 means identity. In terms of matrix language, 1 means identity. Phi 0 has to be equal to identity, right? Phi 0 has to be equal to identity. That is what you have to make sure. Now, that means when you place t equal to 0, identity matrix should. Okay, so anyways, this is not 1. This is not possible. Okay, if you put t equal to 0, then identity should come. If you put t equal to 0, you get 0. This is also wrong. If you put t equal to 0 here, this also becomes 0, wrong. So only option left is C. Only option left is C. When you put t equal to 0, e power 0, 1, 1, and t equal to 0 will make it 0. Okay, phi 0 is identity. Okay, this is number 1 point. Okay, number 2 point. Okay, the inverse of the transition matrix phi inverse t is always equal to phi of minus t. But I think only with this first point, only option number C matches. Phi 0 equal to I, only C option matches. That is also a small point to be noted in case of transition matrices, state transition matrices. Simple one. the state equation of a LTI system is given. Okay, this is the B matrices, which is corresponding to, you know, 2 input case, but okay, need not worry about that. Okay, because if it is single input case, B matrix is a column structure. 2 columns means 2 inputs will be there definitely. Forget this, the closed loop poles, okay, are just equal to what? Eigenvalues of the matrix A. Even in gate 26, the questions are there around this point. Eigenvalues of the matrix A. Eigenvalues of the matrix A. Now, what are the eigenvalues of the matrix A? Okay, for matrix A, what is the characteristic equation? 2 cross 2 matrix. Okay, what is the simple characteristic equation for a 2 cross 2 matrix? Lambda square minus trace into lambda plus determinant equal to 0. Lambda square minus trace is minus 1, and determinant will be 0 minus minus, that is 2, equal to 0. So that is lambda square plus lambda plus 2 equal to 0. Solving for lambda, minus b plus minus root over b square minus 4ac. Okay, so 4 into 2, that is 8. Okay. So lambda is minus 1 plus minus under root minus 7, that is j root 7 by 2. Okay, so lambda is minus 0.5 plus minus j. This is minus 0.5. So definitely, if I calculate this value, I should get this number. Okay, what is the number? Root 7 is divided by 2. Yeah, 1.33 approximately. Okay, plus minus j 1.33. Okay, option number C. Option number C directly. Yes, Samukha correct, Harshvardhan correct. Option number C here. Okay, option number C. Next variety of question. The state representation of a system is given to you, x dot equal to ax and y equal to cx, and x0 initial state is given, time response of the system. Now you see here. Okay, now here normally what is the system given? X dot equal to ax, whereas it should be ax plus bu. Okay, that means input is 0. Okay, and input 0 means which type of response we calculate? ZIR, 0 input response. Okay, so time response here is ZIR. Okay, and first we have to solve the state equation, then output equation. Now, what is the state equation? 0 input response, xzirt, if I talk about xzirt, okay, is simply given by e power at into x naught. Okay, phi t into x naught, where phi t is the state transition matrix, that again we have to find here. Okay, multiplied by x naught, the initial state given, which is the initial state given. Okay, so what is the state transition matrix? This we have to again figure out here. So what is that state transition matrix? Matrix A is given to me 0, 1, minus 2 and 0, correct? 0 and 1, minus 2 and 0. So I will again write down first Si minus A. What is Si minus A? S0, 0, S. This is Si minus the A matrix 0, 1, minus 2 and 0. This will be S minus 0, 0 minus 1, 0 minus minus 2 and S minus 0. Okay, now I have to find Si minus A whole inverse. And what is the inverse of the matrix? Inverse of any matrix is adjoint of it divided by the determinant of it. This will be how much? Adjoint means change the diagonal numbers, which are same anyways, and change the sign of the off diagonal numbers, plus 1, minus 2, whole divided by S square minus minus plus 2. This is the determinant. Okay, when you take the term inside, it will be S upon S square plus 2, 1 upon S square plus 2, minus 2 upon S square, and last term S upon S square plus 2. Okay, now we have to take the plus cos root 2t. Okay, this is what it is. Okay, now what is the output equation? Output equation is given as 1 minus 1 into x, or if you write this way, output equation yt is equal to 1 minus 1 into xt, where xt, the state vector, contains of two states, x1 and x2. So when you open it, you will get x1 minus x2. This is x1, this is x2. Okay, when you subtract these two, cos root 2t will get cancelled. Your answer will be 1 by root 2 plus root 2 sin root 2t. and when you simplify, root 2 into 2, 2 plus 1, 3 by root 2 sine root 2t. Okay. This is the state vector containing both the state variable. This is x1, this is x2. So I have subtracted them. 3 by root 2 sine root 2t. 3 by root 2 sine root 2t. Option number B. 3 by root 2 sine root 2t. Correct? Oh, I could not see whether it buffered in between. Maybe for a few seconds it buffered. Yeah, but this is what? 3 by root 2 sine root 2t is the answer we have got here. Okay. 3 by root 2 sine root 2t. Okay. One last question for today that I will leave as a homework for you. This is on ZIR. That also we have done. Okay. One last question as homework. Okay. Transfer function. If they ask you the transfer function, how do you calculate the transfer function? Transfer function generally will be calculated by the formula C into phi s into B plus D. Okay, where every data is given to you. Okay, what is the D? D is nil. Okay, y equal to Cx plus du. There is no D. Okay, this is the C matrix. This is the B matrix. Both of them are given. Only thing you need phi s. What is phi s? Laplace transform of state transition matrix, Si minus A whole inverse. This calculation in 2-3 questions I told you, same calculation you have to do, Si minus A whole inverse. First calculate Si minus A and then adjoint upon determinant. Okay, so I hope you can complete this part. Okay, but just one more model of question where they can ask you directly the transfer function. Okay. So complete this question as homework. Formula also I have written to you. How to calculate phi s we have done in the 2-3 questions. So that is why I think you can handle. C and B are the matrices given to you. This is the A matrix. Anyways, you know it. This was on the ZIR, the time response, but ultimately ZIR because input was not given, means zero input. Okay. Also guys, quick and important updates for you that if you or if your friends or juniors or colleagues, anybody willing to prepare for GATE in a very serious manner, in offline manner, coming down to Hyderabad and taking the direct guidance from the faculties and also studying in a competitive atmosphere with lot of dedication, you know, the preparation happens in offline. So you can enroll for our GATE 2027 offline course. The first offline course just started 26th February. Okay, so you can enroll into it very quickly. Okay, we'll announce new batches as well, but early you start, early you finish the syllabus, and more the time you get for revision and test, better will be your final rank. It is available for both EC and EE. Okay, and for any details you can contact our support numbers. I'll tell you that as well. Right, but in case if you are a college going student and you cannot anyhow manage to come to Hyderabad for offline, you can still want prepare for GATE 27. Okay, and online course is available for GATE 2027 as well as 2028, 1 year and 2 year module. Okay, that started just 24th February. So you can also enroll into this course, that is online live course. Because it's a live course, still you can have quick interaction, anything that is troubling you in the class, any doubts, any interaction with the faculty, you can do it immediately. And if you're looking for courses of the AE, the Telangana and Andhra Pradesh Genco Transco Discoms, the next offline course 27th of February. Okay, for any more details regarding any course, okay, you can immediately contact this number 95156940053. Okay, a team will be more than happy to help you. This is our main website, ominstitute.com, and if you want the information about the live courses, ominstitute.live. This is a landing page. You can go. This is our official Telegram handle, and this is the address of our physical address of our Hyderabad center. We are located at the Kothapet location of Hyderabad. Okay guys, now for any more personal interactions and query with me, you can connect me. This is my personal Telegram. Okay, you can search using this name. Okay, and also as always, I'll share you the the PDF of my today's session, but PDF is always password protected. Okay, and the password for today's PDF will be what? Okay, last question was on transfer function. Transfer. The password for today's PDF, transfer, everything in small, TRANSFER, everything in small. Please note down the password. The PDF will be shared in my Telegram group mentioned here, but it is going to be password protected so that those who are dedicatedly learning and those who are actually preparing for BARC, the PDF is meant for them only. Okay, so that is the reason I put down the password protection here, transfer. Okay guys, thank you, and see you in another session. Okay, other subjects will also be continued for you with respect to the BARC series. Okay guys. Yeah, so I'll see you in the next sessions. I'll first take the next session on signal and system, and tomorrow you can expect the session on electromagnetics. Okay, tomorrow you can expect the session on electromagnetics for EC, and then the day after tomorrow, machines. Okay, core subject, machines for electrical students. Okay, okay guys, bye bye. Thank you. Stay safe and take care of yourself.